At 8:30 in the morning on February 20, 1944, the first bulldozer rolled onto the shattered coral of Engebe Island. The island was quiet now, but only hours earlier it had been the target of one of the most concentrated naval bombardments in the Pacific War. Battleships of United States Navy Task Force 58 had fired hundreds of 14-inch and 16-inch shells into the narrow strip of land. Carrier aircraft had dropped bombs across the jungle interior. By dawn, assault companies of the United States Marine Corps 4th Marine Division had secured most of the island. Yet for the planners aboard the command ship offshore, the capture of Engebe was not the final objective. It was only the beginning. The real goal was an airfield. At 9:15 in the morning, a landing craft ramp dropped against the coral shoreline. A yellow bulldozer belonging to Company B of the 75th Naval Construction Battalion, part of the famous United States Naval Construction Battalions, slowly crawled onto the beach. The driver was Chief Petty Officer James Harwood, a construction mechanic who had spent years operating heavy equipment before the war. His machine was a Caterpillar D7 bulldozer, weighing nearly 20,000 pounds and powered by a 90-horsepower diesel engine. Behind him came graders, scrapers, and coral crushers. The engineers had a single mission: build a combat airstrip in 72 hours. The operational requirement came directly from Admiral Raymond A. Spruance, commander of the United States Fifth Fleet. His fleet carriers could not remain near the Marshalls indefinitely. Japanese land-based aircraft operating from Truk Lagoon still posed a serious threat. An airfield on Engebe would allow F-4U Corsair and F-6F Hellcat fighters to establish a permanent defensive umbrella. Without it, the newly captured atoll would remain dangerously exposed. At 10:40 in the morning, Seabees survey teams began marking the proposed runway. Lieutenant Commander Robert Fields, the battalion engineering officer, walked the ground with a clipboard and measuring rod. The island presented a major problem. Engebe was only 1.4 miles long and half a mile wide. Much of the interior was tangled with palm trees and bomb craters from the naval bombardment. The ground beneath the thin soil layer consisted of coral limestone that could either support heavy aircraft or shatter construction equipment depending on how it was cut. The target runway length was 4,000 feet. That was the minimum distance required for a fully loaded Grumman F-6F Hellcat fighter to take off safely in tropical heat. At 11:30 in the morning, demolition teams began clearing the first line of palm trees. Seabees used TNT demolition charges weighing half a pound each, wiring them around tree bases in clusters of 3. When detonated, the blasts snapped trunks and scattered debris across the clearing zone. Bulldozers immediately followed. The machines pushed tangled roots and broken palms into long burn piles. Behind them, Marine engineers from the 4th Pioneer Battalion used flamethrowers and diesel fuel to ignite the piles. By 2:15 in the afternoon, the first 500 feet of runway had been cleared. But the real engineering challenge was still ahead. The coral surface had to be crushed and compacted to support aircraft weighing more than 15,000 pounds. If the surface fractured under landing gear, the entire runway would become unusable. To solve this, the Seabees deployed 2 coral crushers, machines designed to grind limestone into small aggregate. Dump trucks carried crushed coral to the runway line, where graders spread it into layers roughly 6 inches thick. Each layer then required compaction. Without proper compaction, propeller wash from fighter aircraft could blow the surface apart. By 5:30 in the evening, nearly 200 Seabees were working under fading sunlight. Portable floodlights powered by diesel generators illuminated the construction zone. No one stopped. The 72-hour clock had already begun. At 7:10 in the evening, a radio message arrived from Fleet Headquarters. Japanese reconnaissance aircraft had been detected approaching the Marshall Islands chain. If enemy bombers struck before the runway was complete, the construction equipment on Engebe would have almost no protection. Lieutenant Commander Fields looked across the half-finished runway. Only 800 feet had been compacted. More than 3,000 feet remained. And somewhere beyond the dark horizon, Japanese aircraft might already be on their way. By 6:20 in the morning on February 21, 1944, the runway on Engebe Island had reached a length of 1,400 feet. The progress had come through an entire night of continuous work. Portable floodlights illuminated the construction line. Diesel generators hummed across the beachhead. Bulldozers pushed coral debris while graders leveled the expanding runway strip. Men from Company B of the 75th Naval Construction Battalion rotated in short shifts, but the machinery never stopped. The airstrip was no longer simply a construction project. It had become a race against time. The strategic pressure came from the wider Pacific campaign. Admiral Raymond A. Spruance, commanding the United States Fifth Fleet, had ordered the rapid airfield construction for a clear operational reason. The United States Navy was advancing across the Marshall Islands chain. Each newly captured island needed fighter coverage to defend transport ships, supply convoys, and the fleet carriers that supported amphibious operations. Without land-based fighters, American naval forces remained vulnerable to long-range Japanese bombers. Aircraft from Truk Lagoon could reach the Marshalls with enough fuel to strike and return. Japanese planners had already used that base to launch reconnaissance flights over American naval formations. An operational runway on Engebe would place American fighters less than 400 miles from Truk. That distance mattered. It meant that Grumman F-6F Hellcat fighters could escort bombing raids and intercept reconnaissance aircraft long before they reached the fleet. But the runway still existed only as a partially compacted strip of crushed coral. At 7:45 in the morning, Lieutenant Commander Robert Fields gathered the construction foremen near the center line markers. Using a field map drawn the previous evening, he reorganized the work crews. The runway was divided into 3 active construction zones. Zone 1 handled tree clearing and debris removal. Zone 2 focused on coral crushing and transport. Zone 3 handled leveling and compaction. This division allowed equipment to operate continuously without interfering with other crews. The heaviest machines remained the Caterpillar D7 bulldozers. Each machine pushed nearly 3 cubic yards of coral rubble per pass. The bulldozers fed material toward a pair of mobile rock crushers operated by Seabee mechanics. Those crushers were critical. The coral limestone of Engebe contained sharp fragments that could destroy aircraft tires if left untreated. The crushers reduced the coral to smaller aggregate, roughly 1 inch in diameter, making it suitable for runway surfacing. Once crushed, dump trucks transported the material to the runway. Graders then spread the coral across the strip in layers no thicker than 6 inches. After leveling, compaction teams followed. Seabees used heavy steel rollers weighing nearly 8 tons. The rollers passed over the coral surface repeatedly until the aggregate locked together into a hardened layer. By 10:15 in the morning, the runway measured 2,100 feet, nearly halfway. But the work pace began to slow. The island's surface became uneven toward the eastern end. Bombardment craters from naval artillery created deep pits that had to be filled before the runway could continue. Some craters were nearly 20 feet across and 6 feet deep. Filling them required truckloads of crushed coral. Every crater added hours to the construction schedule. At 11:50 in the morning, a lookout on the western shoreline spotted something troubling. 2 aircraft silhouettes appeared high above the horizon. The shapes were soon identified as Japanese reconnaissance planes. Although the aircraft did not attack, the sighting confirmed what fleet commanders feared. The enemy knew the island had been captured. If bombers followed, the construction site would become an obvious target. Bulldozers, fuel drums, and coral stockpiles sat fully exposed along the unfinished runway. There were almost no defensive positions nearby. Marine infantry units had moved inland to secure the rest of Enewetak Atoll, leaving the Seabees largely responsible for their own security. At 2:20 in the afternoon, work resumed at full speed despite the risk. Bulldozers cleared the final line of palm trees along the eastern end of the proposed airstrip. Coral crushers continued grinding limestone while dump trucks ran continuous loops between quarry sites and the runway. By 4:45 in the afternoon, the runway length reached 3,000 feet. That number held enormous tactical significance. At 3,000 feet, light fighter aircraft could attempt emergency operations if absolutely necessary. However, the runway still lacked proper width and compaction. The required width was 150 feet. At that moment, only about 90 feet had been fully graded. If an aircraft attempted landing now, a slight drift during touchdown could send it directly into loose coral or construction equipment. As evening approached, Lieutenant Commander Fields calculated the remaining work. Nearly 1,000 feet of runway still required clearing, leveling, and compaction. And the most difficult ground remained ahead. The eastern section of the island contained coral ridges that rose above the surrounding terrain. Those ridges would require heavy bulldozer cutting to level the surface. Without removing them, the runway would slope dangerously upward. At 6:30 in the evening, diesel generators flickered back on as darkness fell across the island. Floodlights illuminated the machines once again, but now the workers understood something new. Japanese reconnaissance aircraft had already seen the construction. If bombers arrived during the night, the half-finished runway might be destroyed before the first American fighter ever touched down. And with less than 24 hours remaining in the 72-hour deadline, the Seabees still faced the hardest section of the island, a jagged coral ridge running directly across the planned runway line. Removing it would require hours of cutting, blasting, and leveling, time that the construction crews might not have. At 5:40 in the morning on February 22, 1944, the eastern end of the runway on Engebe Island was still blocked by a coral ridge nearly 3 feet above the planned surface level. For the Seabees of Company B, 75th Naval Construction Battalion, that ridge represented the final barrier between a construction site and a functioning combat airfield. The 72-hour deadline was approaching rapidly. Lieutenant Commander Robert Fields studied the ridge under the pale morning light. The coral formation stretched across nearly 180 feet of runway width, forming a hard limestone spine that bulldozers had struggled to cut during the night. If the ridge remained, aircraft landing from the west would encounter a sudden upward slope near touchdown speed. That could flip a fighter or collapse landing gear. There was no option to leave it in place. At 6:10 in the morning, demolition teams from the 4th Marine Division Engineer Battalion prepared explosive charges. The plan was simple but risky. Instead of slowly grinding the coral down with bulldozers, engineers would blast the ridge apart in a controlled detonation. The charges consisted of blocks of TNT weighing 1 pound each, wired into clusters along drilled holes in the coral surface. Nearly 50 pounds of explosive were placed along the center line of the ridge. Bulldozers pulled back. Dump trucks halted. At 6:35 in the morning, the demolition signal was given. The blast shattered the ridge in a sharp crack that echoed across the lagoon. Coral fragments erupted into the air before falling back across the runway alignment. Within seconds, the bulldozers returned. Operators driving Caterpillar D7 machines pushed the shattered coral outward, clearing the runway line and feeding the fragments toward the crushers for reuse as runway aggregate. By 8:20 in the morning, graders leveled the final section. Rollers followed immediately behind. The compaction process was critical. Each pass of the 8-ton steel roller forced the crushed coral into a tight, interlocking surface capable of supporting aircraft wheels under heavy braking loads. At 9:55 in the morning, Lieutenant Commander Fields walked the entire runway length with a measuring rod. The airstrip now stretched 4,100 feet long and 150 feet wide. The surface was not perfect. Small ridges of coral dust remained along the edges, and construction vehicles still sat nearby. But structurally, the runway could support fighter aircraft. The construction had taken just over 48 hours since the first bulldozer reached the beach. Now came the true test. At 10:30 in the morning, a radio message was transmitted from Engebai to nearby naval forces. The message was brief: runway operational for fighter landing. Within minutes, the signal reached the flight deck of an aircraft carrier operating with the United States 5th Fleet. A pilot from a Marine fighter squadron climbed into the cockpit of a Grumman F-4U Corsair. The aircraft carried a 2,000 horsepower Pratt & Whitney R280 engine, capable of speeds exceeding 400 miles per hour. However, landing on a freshly built coral runway presented serious risks. Loose coral could damage propellers. Dust clouds could obscure visibility. Uneven compaction could collapse landing gear. At 11:25 in the morning, the Corsair approached Engebi Island from the west. Seabees gathered along the runway edges. Bulldozers idled nearby while engineers watched the aircraft circle overhead. The pilot made one low pass to inspect the surface. From above, the runway appeared as a pale strip of crushed coral cutting across the narrow island. Palm stumps and construction debris remained scattered along the perimeter. The fighter climbed and turned for final approach. At 11:32 in the morning, the Corsair descended toward the runway. The aircraft crossed the shoreline at roughly 100 miles per hour, landing gear extended. For a moment, the wheels hovered just above the coral surface. Then the tires touched. A burst of pale coral dust exploded behind the landing gear as the aircraft rolled forward. The propeller wash blasted loose particles across the strip, but the surface held. The Corsair continued rolling. 1,000 feet, 2,000 feet. Then the pilot reduced power and brought the fighter to a controlled stop near the midpoint of the runway. Cheers erupted from the construction crews. The airstrip, built in barely 2 days, had passed its first operational test. Within hours, additional fighters arrived. By 2:15 in the afternoon, several Grumman F-6F Hellcat aircraft had landed and refueled on the new field. Mechanics established temporary service points using fuel drums and portable pumps. The strategic impact appeared immediately. With fighters now based on Inuiatik Atoll, the United States Navy extended its air defense perimeter hundreds of miles westward. Japanese reconnaissance flights approaching the Marshalls would now encounter intercepting fighters long before reaching American ships. The airstrip also enabled a new phase of operations. Long-range bombers could now stage through the atoll to strike enemy bases deeper in the Central Pacific. The single coral runway helped secure a forward foothold that would support the next American advance toward the Mariana Islands and eventually toward the Japanese home islands. The bulldozers continued working even after the first landing. Taxiways had to be expanded, fuel dumps constructed, aircraft revetments dug along the jungle edges. Because in the Pacific War, capturing an island was only the first step. Turning it into an airfield was what allowed the war to move forward.